All right, everyone. Today, we're doing a technical teardown of a project you absolutely need to have on your radar, Project NANDA. Now look, this isn't just another agent framework. This is way more fundamental. It's aiming to be the foundational infrastructure for the entire Internet of agents. So let's pop the hood and see what makes it tick.
To really get what NANDA is all about, you have to start with this question. I mean, think about it. Everything we've built, the entire protocol suite from DNS to HTTP, it was all designed around human timescales, human interaction, human trust models. And that architecture, it is about to hit a massive, massive wall.
In this slide right here, this lays out the paradigm shift perfectly. We're moving from our web, the human web, where waiting a few hours for DNS to propagate is, annoying but fine. But we're going to an agentic web, where trillions of agents might spin up, do a job, and disappear in seconds. They need machine speed discovery, they need fleeting cryptographic identities, and they need trust to be completely automated. Our current setup just can't do that. No way! So that brings us to the core architectural challenge. The moment you start thinking seriously about large-scale multi-agent systems, you realize the web we have today isn't just kind of slow, it's a fundamental bottleneck.
You can really boil the whole problem down to these three massive challenges. First up, discovery. How on earth do you find the one agent you need in a sea of trillions? It's a signal-to-noise nightmare. Second, verification. Okay, you found one. How do you cryptographically prove it is who it says it is and establish a root of trust? And finally, coordination. How do you get them all speaking the same language, or at least understanding each other, without forcing everyone into a single rigid standard?
So what's the answer? Well, that brings us to the vision coming out of the MIT Media Lab, Project NANDA, and this idea of an open agentic web.
Their whole mission is to build this purpose-built infrastructure for this new web, and they see this as the Internet's third great transformation, right? First was static pages, then dynamic services, and now autonomous agents. A key part of their thesis, and this is so important, is that this foundational layer has to be open and decentralized. It has to be, or it'll just get captured and siloed by a handful of big tech companies.
Okay, so how are they actually going to pull this off? Let's get into the core technical stack. This is where we get into the real engineering, the nuts and bolts of it all.
It's actually pretty elegant. They've built these three pillars, and you'll notice they map directly to the three big challenges we just talked about: discover, trust, and coordinate. Let's break them down one by one.
So first up is the NANDA Index. The key phrase here is post-DNS registry. So instead of mapping a domain name to a static IP address, the index maps a friendly handle, like @mycorp/billing-agent, to a dynamic living document. It's also federated in what they call a quilt-like model, which is cool. It means an enterprise can run its own private registry that still plugs into the global discovery network. And as engineers, this is where it gets really interesting. The architecture makes some serious guarantees. We're talking sub-second global resolution for finding an agent. And just as critical, sub-second revocation if an agent is compromised. It's also built for endpoint agility, so you can do things like blue/green deployments or geo-failovers without ever breaking the agent's core identity. That's huge.
I love this analogy from their docs. It's just perfect. The index is the address book. It tells you where to find an agent. But the AgentFacts document, that's the passport. It tells you who the agent is, what it can do, and most importantly, why you should trust it. It's really the atomic unit of identity for this entire ecosystem.
Okay, so let's look at the structure of this thing. It's a cryptographically signed JSON LD file. You've got the ID, which is a decentralized identifier, giving it a stable identity. You've got the owner, which gives you provenance, who's running it. Then you have capabilities, which is a machine-readable list of skills using URNs. And the whole thing is wrapped in a JSON Web Signature, which makes it totally tamper-proof. This is the bedrock of trust in the system.
The final piece of the puzzle is the Adapter SDK. And this is smart. They recognize that we're probably never going to get one single monolithic communication standard that everyone agrees on. So instead, they give us a universal translator. You can just wrap your existing agent in this SDK, and boom, it can now speak multiple protocols. It's a super pragmatic way to solve that interoperability problem.
All right, let's switch gears and talk about strategy. Because to be honest, I think this is the most brilliant part of the entire project. It's not just about what they're building, it's about where they're building it in the stack. To really get NANDA's strategy, you have to see where it fits in the wider landscape. You've got the Linux Foundation's A2A protocol for agent-to-agent talk. You've got Anthropic's MCP for agent-to-tool comms. See, NANDA isn't trying to be another one of those. It's answering a much more fundamental question. Who are you, and where can I find you?
And this, right here, is the key insight. The A2A protocol has massive industry backing. We're talking Google, AWS, Microsoft, pretty much everyone. Trying to compete with that would be a losing battle from the start. So NANDA doesn't. Instead, it positions itself as the essential underlying service that A2A actually needs to work at a global scale.
And this is what that strategy looks like. You've got A2A and MCP operating up at Layer 2. They define how agents talk, but NANDA slots in underneath, providing the foundational Layer 0 and Layer 1. It's the DNS and the certificate authority that A2A needs for agents to find and trust each other in the first place. This makes NANDA a symbiotic partner, not a competitor. It's just a genius move.
Okay, so as engineers, as architects building in this space, what's the bottom line? What are the practical takeaways from all this? What should we actually be doing?
Well, it really boils down to 3 things. First, monitor this project, seriously. Keep it on your tech radar because it is solving a problem that every single person building multi-agent systems is going to run into. Second, if you can, contribute. It's all open source, the spec working group is right there on Discord. Getting involved now means you can help shape it. And finally, pilot it. The cost of experimentation is basically zero. Spin it up for a small multi-agent pilot and see the value for yourself.
You know, in the end, if NANDA is successful, most people will never even know it exists. Just like most people have no idea what BGP or DNS really are. It'll just be there, the invisible but absolutely indispensable nervous system that lets a global society of intelligent agents connect, trust, and collaborate with each other.
So I'll leave you with this final thought. NANDA is basically a bet. It's a bet on an open, decentralized future for this new agentic web, one that's built on community-driven protocols. The alternative, of course, is a future of walled gardens controlled by just a few massive companies. As the engineers who are actually building this future, the choice of which path we support, well, that's ultimately up to us.